So welcome to the Q&A. We are here to ask a few more questions to Heather, our brilliant presenter who is talking about how she uses mathematical formula to study decision making in mice. And to start off, we have a question about the candy you use to reward the mice. Is too much candy bad for the mice?
Yeah, great question. So too much candy, just like for humans, would be bad for the mice. That's why. So when I have the mice play these games, they only do it for a couple hours a day. So like for the maze game, they can play the game for 2 hours each day. So that limits the amount of candy they can get. That way that they don't eat too much, because mice can get things like diabetes too if they eat too much sugar, just like humans.
And then, sort of speaking of the mice, what kind of things might influence the result? Like maybe, sort of going on the candy, if they're like full, do they not want to play the game? If they're male or female, would that change? How old they are, would that change? Something like that.
Yeah, all of those factors change how the mice play the game and what strategies they use to make decisions. So I think the first part of that question was if they're full or not. So if you're full or not and you're playing for candy, a lot of that plays into motivation. So if you're full, you're not going to want to exert the energy or the effort to press that lever a bunch of times to get candy. Whereas if you were like a little bit hungry or you hadn't had candy yet today and you weren't like, if you eat too much candy, you kind of get a little bit sick of it. You're more motivated to press that lever a bunch. So that factors into how long they'll play the game for.
Um, Kind of going off that, I think people who watch your talk, you have this sort of concept called beta that's part of your equation. So, sort of connected questions. Would these, like the fullness of the mice, does that change beta or a different part of the equation? And what is beta again exactly?
Yeah. So beta is a variable that we add to our equation that we calculate based on the mouse's behavior. So it's not something we directly measure, like which direction they want to go in the maze. So it's not like it when they choose left or right. That's something we measure from the game. So we have to calculate beta. And we calculate beta from their choices and their decisions, and beta will tell us about their decision making strategy. And beta is specifically a variable that tells us about randomness. So with a beta of 0, the mice have no randomness and will have perfect. Talked about the win, stay, lose, switch behavior, where if they get candy, they'll repeat that same behavior. And if they don't get candy, they'll change their behavior. And that's kind of the perfect behavior for no randomness. There's no variability in the choices they make. Every time they reliably follow that formula to make the same type of choice. But if we have different amounts of beta, so if we have a really high beta, like a beta of 10, that would be a really high beta. The mouse would be really random. So if they got candy, there'd be like a 50-50 chance that they repeat that action or they choose the other side. And that changes based on your beta, and you can have betas for each choice, or each mouse can have a beta. So like my beta might be different than Grace's. And we calculate that based on the choices we make in a game like this one.
So I guess it seems like to me that then the fullness we talked about, it would influence the beta because it would make it more likely that you would not care about the game and therefore wouldn't choose based on the food? Or is that an incorrect understanding?
I don't know. That's a really good question. I think being full could change beta. Because if you're really full, you might not go with randomness and kind of explore or make like risky decisions or explore other options. Um, but if you're really hungry, you might want to take chances to like try and figure out if there's something better out there. So yeah, I think beta could factor into it, but I really don't know. I haven't tried that
Interesting.
variable or changing that in my experiment.
And finally, just to talk about your experiment, why is it important to follow the protocol of the win, stay, lose? habit?
Yeah. So it's really important to follow that habit because when, like, let's say where the mice are wild in the environment, their main goal is to find food. So if they find food going in one direction, they want to do that same thing the next day. They want to go in the same path. So if they win on that path and get food for that day, they want to do the same thing. So they're likely to get food because food is scarce. Or they're not likely to find food if they take one of the other hundreds of paths they could take. But if they take a path or they don't find food, which would be a lose situation, they don't want to take that path again because it's very unlikely that they'll find food there. And since food is so important for their survival, they're going to want to err on the side of the win stay, and make sure that when they lose, they switch to the other one so they have more chances of getting into that win stay behavior so they have reliable food.
Wonderful. Well, thank you for explaining that for us,
Yeah,
Heather. And thank you again for such a great presentation.
thank you.
Okay, so we're back with Sooyun. She talked to us about the chemistry of food and cooking, a little bit about the cooking. I first of all want to thank you for giving me my new favorite fact. Blueberries are my favorite food, and my name is Delphina. And you mentioned that the compound in them was it delphinidin?
Mhm.
My new favorite fact. Thank you so much for that.
I'll be your share.
So there were some really cool questions that came up in the chat that we didn't get to during your presentation. But one of the ones that kept coming up was, how did you know that you wanted to be a chemist?
I guess up until high school, I didn't know that I wanted to be a chemist. I like sort of almost felt like science wasn't for someone like me, but that changed because I realized that I was passionate about learning more about the world and specifically what composed in the different things that make up our world. So as I studied about the different chemical makeup of the different things around us, I realized that I wanted to be someone who makes those, someone who makes a chemical. So I became a synthetic chemist.
So along those lines, like where you're at right now, and the projects that you're working on, what is it that your work will be used for in the future?
That's also a great question. So I'm making an NQ selective reaction methodology, and having these ways to access different chemical structures in an efficient way can allow us basically to have a big toolbox to make different molecules that will be useful in our lives, such as medicine and different polymers and different chemicals that can be found in daily lives.
That's awesome and very hopeful prospects to the future for sure. So at the very beginning of your talk, you had some definitions of, Merriam-Webster dictionary definitions of what is a chemical, and like went on to talk about how chemicals are basically in everything. So with that in mind, I was curious about how you as a chemist would define a chemical.
Yeah, so I think a chemical isn't something that's artificially prepared. Chemical is everything in the world, what everything in the world is made of. So that's how I would define it, I think.
Okay, cool. And so with that, like everything is made up of chemicals, so that means that everything has bonds of some sort, right? So what is a bond exactly?
A bond is the interaction between two atoms that keeps it bound to each other to form a structure between the atoms. And to define a simple, basically, yeah, it's a connection between the two atoms.
All right, cool. And so since chemicals are in everything in some way, shape, or form, would you say that they're dangerous? Like, what about drugs or like water? Water is a chemical. Why isn't water bad for us?
That's a good point. So I would say that there are very dangerous chemicals, but not all chemicals are dangerous. And as I had shared in the presentation, what makes a chemical dangerous to us is the amount. So some chemicals, we can have a lot of it before it's harmful to us, but some chemicals, if even if we have a little bit of it around us, it can definitely hurt us in some ways. So that's what I think is interesting about chemistry.
So one of the questions that came up in the chat that I thought was interesting was this idea of, the size of vegetables or fruits or an organism. Does that necessarily mean that they have bigger molecules, or like what would you consider a big molecule versus a small molecule?
Sure. I think that's an interesting question for sure. I think larger fruits and vegetables don't have bigger molecules. They just have more of these molecules. They have more mass. And I think there's a lot of different definitions in terms of big versus small molecules. I think some of the big molecules that we can think about are like polymers of, let's say, DNA or protein. These are biomolecules that are made up of smaller molecules in a chain. And these are definitely some of the larger structures chemically.
So, all of these different, molecules and chemicals combine to do a lot of different things. So one of the other questions that came up was, why was it that the formulas of some of the pigments you were talking about, or some of the the more odorant chemicals, they look very similar, but just a small little change made it smell or look completely different.
Right. So so the first part of it, where it looks different color, is that the different chemical structures can allow it to absorb different wavelengths of light, which is what gives it its characteristic color. And in terms of smell, we talked about the structure of the molecule. So even a small change in the shape of the molecule can change the receptors it may bind to in our body, which would control what kind of smells we're experiencing through our brain.
Awesome. Okay, so more to like, when fruits and vegetables start to go bad or they get good and then they go bad, like what is that chemical process like? And is there some way that we could like either chemically treat the vegetables or change them genetically or somehow prevent them from smelling if we get rid of these chemicals?
That's a good question. I think there's definitely chemical changes happening to these odor chemicals that makes it smell different and bad sometimes. I think in terms of removing the chemicals from the vegetable, theoretically, if we can remove all of the compounds that have that characteristic smell, maybe theoretically it's possible. But if these molecules serve a different purpose in these things, in the vegetables and fruits, then maybe it won't be the same anymore, right? Like it might not, like if we remove some chemicals from an apple, will it still be an apple? If like that chemical doesn't only give it its smell, it has serves a different purpose.
So I guess, sorry, this is like other follow-up questions that are like just like jumping to mind right now. So, um, some of those chemicals that make the fruits and vegetables ripen, like before they get to that ripe point, do they have another purpose, or is their job basically to like tell other animals or whatever, don't eat me because I'll poison you, or survival mechanism things?
I'm sure there are chemicals that served different purposes at the same time. I'm not 100% sure of specific examples.
Okay. Okay, awesome. Well, I think that wraps up the questions that the chat had, the questions that I had. But is there anything else that you want to say to the participants, or, words of encouragement that you want to pass on to them?
Um, I'm going to thank everybody for hanging out with me today. I had a really great time. And I guess I just want to say that chemistry is super cool. It's really fun, and working in the laboratory is a really great experience. So I'd encourage you guys to explore it and try it out.
All right, thank you, Sooyun. It was good talking to you.
Thanks.